This is MTS 102 class, and the course title is Introductory Mathematics 2, and the course is 3 units. Under this, we have 7 study sections where we have functions of free variables, limits and idea of continuity, derivative as limit of rate of change, techniques of differentiation, basic principle of integration, method of integration, and application of integration, respectively. For today, we are going to work on functions of real variables. Functions of real variables. This is the course objective under the functions of real variables. The content few are mentioned here. So we now move to the introduction proper. In mathematical analysis, applications in geometry, applied mathematics, engineering, and natural sciences, a function of a real variable is a function whose domain is the real numbers or a subset of that contains an interval of positive length. Look at the learning outcomes there. It is by the end of this course, students should be able to define basic terms such as function, periodic function, monotonic function, even and odd functions, and also identify one-to-one function, onto function, composite and inverse functions, and also be able to solve problems on functions of real variables. What is a function? What is a function? We say that a function is a relation between a set of inputs called the domain. A function is a relation between a set of inputs called the domain and a set of possible outputs called codomain. And it assigns each input to exactly one output. It assigns each input to exactly one output. Take notes. Let x and y be real numbers such that a relation between x and y such that x is given and y is determined. What are we saying here? If x is given, then you'll be able to determine y. We say that y is a function of x, and x is called independent variable. X is called independent variables, and y is the dependent variable. Here you see that y is the dependent variable, is depending on x. Because without the x, without the value of x, you will not be able to determine y. So if x is given, then you'll be able to determine y. That is why y is depending on x. We have y equal to f of s. Y equal to f of s. So anywhere you see y, you can write it as f of s. It means the same thing. So let's look at this example. If f of s equal to s squared, then if x is given here as 0, 1, 5 respectively, then y is 0, 1, 25, because by the time you input the value of x here, where we have a 0, 1, 5, to the function given, where we have f of s equal to s squared, then you get y to be 0, 1, and 25. For x is 0, y is 0. For s is 1, y is 1, and for s is 5, y is 25. Now we move on to periodic function. periodic function. A function which repeats itself at a regular interval of s is called periodic. We call it periodic. And integral of definition. The range of values of s for y is defined is called the integral of definition. For example, if y is equal to 2, the function is undefined. Why? Because the range of value of s for y is defined is called integral of definition, because you have to get the range of s where you can determine your y. Then we say it is integral of definition. And when it is defined, you have your s. If you have the range at which s is given, then we determine your y. Then we have that the function is what is defined. So let's move on. Here we move to monotonic function. Monotonic function. F of s1 is monotonic in placing if f of s1 less than f of s2, whenever s1 less than s2. And also for monotonic decreasing, we have a f of s1 greater than f of s2 whenever s1 greater than s2. And also we move on to even and odd functions. Even and odd functions. A function, when we have Roman figure 1, a function f of s is said to be even if f of s equal to f of minus x. That is, let's take for example here, where we have this function as s squared minus 1. F of s equal to s squared minus 1. Then substitute the value of s there. That is minus s, substitute it where we have s squared, we have s squared plus 1 as the output. You see that it is even. And if it is odd, let's check this example also, where we have f of s equal to s raised to power of 3. Then substitute the value of s where we have minus s. Substitute then you see that the output is minus s, which is odd function. It is odd. Since it is negative x, it is odd function. Then now we want to explain what is called mapping here. We want to explain what is called mapping. We say that a mapping is a relation which associates every element from domain S into corresponding elements in codomain Y. That is its mapping. Let's take for instance, let X and Y be sets. Let's make X and Y be sets. I believe you understand what is called sets. So a mapping is a relation which associates every element from domain S into corresponding elements in codomain Y. That is, it is a relation between them. That is what we call mapping. And let's check this. Given two non-empty sets, here, given two non-empty sets, A and B, if there is a rule which assigns an element S in A unique element Y in B, such a rule is called a mapping. That is, I'm just explaining it further there. A function is a rule for transforming a member of one set A to a unique member of another set B. That is the explanation on that function there. A function from a set A to set B is a rule which associates with each member of A unique member of B. Then A is called the domain of function and B is the codomain. Now we see that the input is the domain while the output is what? Is the codomain. So the collection of all the images of the element of the domain is called the range. The collection of all the images of the element of the domain is called the range. That is, the range F is a subset of B and consists of all images of numbers in B or elements in B. That is the range. Now let's take for instance here, what is the domain and range of the function f of s equal to s squared. What is the domain and range of the function f of s equal to s squared? The solution: for any real number, its square is uniquely defined. Therefore, the domain of f is the set R. Then the square of any number is never negative, and the square root of any positive real number exists. Therefore, the range is the set of non-negative real number. So let's move to the next slide and see the practical aspect of what we are saying. So look at the solution here, where we have function of s equal to s squared. We want to get the domain and the range from this function. So we have the value of s as 1, 2, 3, and 4. So when s is 1, we get our y as 1. If you substitute 1 into the function given, that is 1 into s squared here, you get 1. Substitute the next value, which is 2, to the function, we have 2 squared. Then we have y is determined there, which is 4. When s is 3, y is 9. And when s is 4, y is 16. So here now, the domain of the function is 1, 2, 3, 4. That is the domain of the function. And the codomain of the function is 1, 4, 9, and 16, which is the output. And the range, from the definition there, where we have the range as subset of B. That is, it consists of all images of members in B. So therefore, the range here is also 1, 4, 9, and 16. And let us look at this figure 1 and figure 2, because we may be referring to it by the time we are explaining other functions. So from here now, from figure 1, we will see that it is a function. Figure 1 is a function. Why? Because a specific element in S is mapping to an element in Y. So it is mapping to a unique element in Y. S from S to Y. 1 is mapping to 1 there, 2 is mapping to 4, 3 is mapping to 9, and 4 is mapping to 16. So when we move on, we still look at one-to-one function, and we get this better. And also looking at the figure 2, we will see that an element in S here, which is A, is mapping to 2 elements in Y. A is mapping to 1, and A is also mapping to 2. So here it is not a function. It is not a function. It's as if a child here is having 2 fathers, which is not possible. It's only father that can have 2 children. So therefore, this figure 2 is not a function. So let's move on. There is another example there, where we have example to find the range and domain of f of s. The solution is there. Also, one-to-one function. Function for which different inputs always give different outputs are called one-to-one function. We also call it injective. We call it injective. It's either one-to-one function or injective. Thus, f of a, such that a mapping b is one-to-one. If f of a equal to f of b implies that a is equal to b, or a not equal to b implies that f of a is not equal to f of b. Note this: if one input gives 2 different outputs, then the mapping is not a function. Can you see it now? If one input gives 2 different outputs, then the mapping is not a function. Just like the figure 2 we cited the other time. Now go to that figure 2, that diagram, you will see what we are talking about here. We see that one element in domain, which is S, is mapping to 2 elements in Y. The Y is codomain, and you will see that it is not a function. It is not a function. And let's also check this example. If f of s equal to 2s plus 1 and x equal to 3, 4, 5, and 6, You know, we're having the value of x here, which is 3, 4, 5, and 6. Substitute to this function given, then we have the specific answer for each values of s, where we have f of 3 is equal to, we have 7, f of 4 is equal to 9. By the time you substitute the value into the function given, then f of 5 equal to 11, f of 6 equal to 13, and so on. So you can see that here it is one-to-one function. Since a specific value of s is given a unique and a specific output, it is one-to-one function. Then let's look at all other examples here where we have f of s equal to 2s. It is injective. It is injective. Why? Because if you have any value of s, substitute into this function, you are going to get a unique output, a specific value. So it is one-to-one function or injective. Also, we have f of s equal to 2s plus 1. It is injective. And f of s equal to s square, it is not injective. Here, it is not injective. Why? Because let's take, for example, we have a plus or minus 2. Substitute into this function where we have s square plus or minus 2. That is, we have minus 2, we have plus 2. Let's substitute the value. When it is minus 2, we have 4. When it is plus 2, substitute, it is also 4. Therefore, it is not a function, and it is not injective. It is not one-to-one. It is not one-to-one function. It is not one-to-one function or injective. So let's go on. We also have f of s equal to s raised to power 3. This also is not injective, because even though if you substitute plus or minus 2 into this, you are going to get a different value. You get different value for minus 2, you get different value for plus 2. So it is injective. And f of s equal to 4s plus 5, it is also injective. So let's go onto function. These are functions whose range is equal to the codomain. It is subjective, while the mapping f is bijective. If it is both injective and subjective, here we say if we have a function that is both injective and subjective, we call it bijective. Another function, a function whose range is equal to the codomain. That is, if we have a codomain, the output of like 1, 2, 3, 4, just like the example we cited the other time, if we have the output to be 1, 2, 3, 4, then the range is also 1, 2, 3, and 4. So let's move to composite function. Suppose f, a, mapping b, and g, a to c are two functions, then g of f is equal to a mapping c, where g of f equal to g of f of s is the composite function. For example, if g of y is this, that is root y plus 5, that is, we are given the function g of y to be root y plus 5, and f of s equal to s square plus 2. We have to find f of 2, f of g of 20, f of 2, f of g of 20. So we have this now, the solution. We first of all look at f of 2. Then where is the function of f of x? Then we have s square plus 2. Then where you see s square, you substitute the value of 2 there. Then we have 2 square plus 2 equal to 6. That is f of 2. Then the next question is f of g of 20. F of g of 20. What are you going to do here? You first of all look at g of 20. Find the value of g of 20. Then after getting the value of g of 20, we now solve for f of g of 20. So that's why we are having g of 20 here, having g of 20 here, which is equal to root 20 plus 5. And you can see it is given here where we have g of y, it is root y plus 5. Then you substitute 20 into y there, you have root 20 plus 5, which is equal to root 25, and the answer is 5. We have gotten g of 20 now. Then we now want to solve for fg of 20. Now take that value of g of 20 to the function given where we have f of s the function given f of s as s squared plus 2. So now substitute 5 back to that, then we have the answer. Then we move to the f of g of 4, then we have the answer as 11. Then we solve for f of 4 first. If we want to solve for g of f of 4, we solve for f of 4 first, we get 18. Then you now substitute to g of f of 4 where we have y plus 5. Then we have root 18 plus 5, which is root 23. That is that. Then we move to inverse of a function. Inverse of a function. Let f such that a mapping b the inverse of f if it exists is the function. Y such that b mapping a such that for all a in a and b in b, if f of a equal to b, then g of b is equal to a. This is invertible function. Call it invertible function. Let's look at the example here for better understanding. You were given the function of s here as s plus 1 all over s plus 2, and we are given g of s to be equal to 3y, g of y to be equal to 3y plus 2. So we are asked to determine all the functions. Determine all the functions here, which is f inverse, g inverse, f inverse of g1, f inverse of g inverse of 2, g inverse of f inverse of 2. So we first of all look at f inverse. Let's look at f inverse here. So for us to check f inverse, we are going to get the f inverse of the function given here. We have to get the f inverse of this function where we have a function of s as s plus 1 all over s plus 2. So here, this is the function. Then we make f of s here, we represent it with any variable, or here it is represented as p. F of s here is represented as p, which is equal to s plus 1 all over s plus 2. Mind you, you know that we want to get f inverse. That is why we are going into this process. So look at it. We cross multiply here. We now get p into s plus 2 equal to s plus 1. So you use your p to open this bracket. You get p of x plus 2p. You get px plus 2p equal to s plus 1. You now take s outside. So you rearrange. Take all the variables that are having x, move to one side, and others without s to the other side. So that's why we have ps minus s equal to 1 minus 2p. So from here we can bring s outside, then we have s into this bracket p minus 1 equal to 1 minus 2p. So here we make the s the subject of formula. We now divide through by p minus 1. Let's divide through by p minus 1. We get s equal to 1 minus 2p all over p minus 1. So here we now have our f inverse. How do we get the f inverse? Anywhere you see p, just replace it as x. From here, anywhere you see p, just change it to x. So we now have our f inverse of x to be equal to what? 1 minus 2s over s minus 1. That is f inverse. We have gotten f inverse now. We have gotten the f inverse. So for us to get g inverse, just the same process, we have given g of y to be equal to what? 3y plus 2. We have given g of y to be equal to 3y plus 2. So we just have to represent our g of y with any variable we like. So here I represent g of y as q. It is represented as q equal to 3y plus 2. So y now is equal to, since it is the one we're looking for, we make y the subject of formula, then we have y equal to q minus 2 over 3. Q minus 2 over 3. So the inverse of g inverse of y now will give us y minus 2 over 3. You just replace, anywhere you see q here, you replace it with y. So you have g inverse now, g inverse of y. That is the first question there. We have answered it. Now we want to get the next one, which is f inverse of g1. F inverse of g1, how do we go about that? We first of all look at the g1, g of 1. So where is the value we are given from the question? We are given the function g of y as what? As 3y plus 2. So you substitute 1 into f, and where you see y, we now have 3 plus 1. 3 into 1 plus 2 equal to 3 plus 2, which is equal to 5. So we've gotten our g of 1. Then from there, we now solve for f inverse of g1. Since we have gotten g of 1 as 5, we now move back to where we have f inverse of x, where we have f inverse of s. What is the what do we get for f inverse of s? We have 1 minus 2s over s minus 1. Then you substitute 5 into where we see s. Then we now have the answer is 9 minus 9 over 4. Also, the next question is f inverse of g inverse of 2. That is the next question there. So for us to get f inverse of g inverse of 2, first of all look at g inverse of 2. And when we substitute into the value of g inverse of 2, where you see g inverse, where we have g inverse of y as y minus 2 over 3, you substitute the value of 2 there, where we have g inverse of 2, put 2 there, where you have y, then the answer is minus 1. After that, you now solve for f inverse of g inverse of 2. Then you have this. So you know you have gotten g inverse of 2 as 0, then you substitute to f inverse of g inverse of 2, then we have minus 1. Also, the next question is g inverse of f inverse of 2. We first of all look at f inverse of 2. Look at the value we got for f inverse, then we now substitute 2 there when we got minus 3. Then after that, we now use that minus 3 to get the g inverse of f inverse. Now, this is another example. Where we have let f of s equal to s minus 1 over s minus 2, where s is not equal to 1 and s is not equal to 2. Find f inverse of s. You know, If s is equal to 1, you know it is undefined. If s is equal to 2, it is also undefined. So therefore, where your s is not equal to 1 and s is not equal to 2, then we have to find f inverse. And this is the procedure. Look at the solution. F of s is equal to s minus 1 over s minus 2. And we now represent our f of s as p. We let f of s to be p. So we now have p equal to s minus 1 all over s minus 2, just as the other the former example we did. Then we cross multiply, get p of s minus 2 equal to s minus 1. And also we use p to open this bracket. We have ps minus 2p equal to s minus 1. Then we rearrange, take the one with s at one side and the one without s at the other side. Then we now take s outside here. We get s into p minus 1 equal to 2p minus 1. Where we want to make the s the subject of the whole formula. Now we now divide through by p minus 1. If we divide both sides by p minus 1, then we get s equal to 2p minus 1 over p minus 1. Therefore, f inverse of s now is now 2s minus 1 over s minus 1. Why? Because anywhere you see p, just represent it as x. So that is f inverse of x. Here we have gotten the f inverse. That is the final answer there. And I believe we have come to the end of this class for today. We have studied the functions, all the subtopic under it. We've done that, and by the grace of God, we are meeting again. Thank you for listening. God bless you.